All right, welcome back, YouTube. This video is going to be a continuation of the Kohler bathtub timer circuit board. I was trying to finish it before I put another video out, but it's been like a couple weeks. I'm still struggling, so I figured I'll make a video and show you where I'm at so far with it, and maybe somebody out there who's better at writing software than me will have some ideas. So stay tuned. Okay, so you can see what I have here. I have, there's the original circuit board. I soldered an Arduino Nano Connect board in here. I mean, I could have just went with a regular Nano, but the Connect was cool and only a couple dollars more. Who knows, maybe at some point we can connect this to the Wi-Fi or something. But anyhow, for now, the Nano was in there. I soldered the Nano in, and you can see it fit right where the other microcontroller chip was. It's a little bit smaller, a few less pins, and the good thing is the pins for the lighting's not very good for some reason. The pins for the LED line up with all of the digital input pin or digital input output pins on the Arduino on the Nano. So all of these line right up perfectly, and so I was able to just use the one after it and the one before it for the switches, and this one over here, D13, I was able to use for the pump, output for the pump. And you can see this is a 3.3 volt board. This board runs on 5 volts. The old microcontroller ran on 5 volts. The Arduino only outputs 3.3 volts. So I made this mess here. I added 2 resistors and 2 transistors. Let's see, I think I drew that circuit somewhere. I'll show you that circuit here in a minute. Basically, I'm using a PNP and an NPN transistor to the PNP turns on the 3.3 volts, and then the NPN takes the 3.3 volts and turns on 5 volts. Anyhow, I needed those 2 transistors to get it to switch 5 volts so that even though this says 3 to 32 volts, I tried it with the 3 volts and it wouldn't turn this relay on. So anyhow, I added this little mess here just to keep the circuit board pretty much the same. I had to have a little jumper wire over the ground. And then on the back side of the board, I added a couple of jumpers. I cut some traces. You can see here, these are all the 7-segment display. They went straight across all these pins. This one I cut the trace off and soldered it to a switch. This one here is the input from the float switch, and I had to tie it high to a 5 volts with this resistor. And this LED is taking, because this is coming from 24 volts AC. I've just bought this brick transformer, or is it 14 volts? It's actually 12 volt AC transformer. We're just putting out about 14 volts AC because that's what the tub has. So anyhow, this diode basically turns it into pulsating DC for the 5 volt regulator. And it does get a clean 5 volt signal. So 4.8 volts or something. Anyhow, a couple other wires from switches to inputs. And that's pretty much it for the back side of the board. I had to cut a bunch of traces. I cut some things. Oh, and this is where that transistor goes in. And I just put a solder blob over to this pin because that's 5 volts and that's power in for the microcontroller. So that's all I did on the back side of the board. Those are the only hardware changes I made to this board. And so let's see it work. Hang on, let me get set up. Okay, so this is what I got. So got my 24 volts plugged in here. Here's my float switch right here. Solid state relay. So when I have this set up for seconds right now for testing. I'll change it to minutes right before I give it to him. So if I press it once, it's 5 seconds. 10 seconds, 15, 19, but it's actually 20. 19 is the highest it'll display. So when I hit run, it's going to stay on 19 for 2 minutes instead of 1. It'll stay on for the 20-minute and for the 19-minute. But anyhow, and then hit it again, it goes back to 0. So if you set it to 5 and then you hit start, you can see the relay comes on, so the pump would come on till it counts down, gets to 0, pump turns off, the timer turns off. Okay? Now the problem is I can hit it again, it goes to 10. I would like it to show 5 again and then hit it and go to 10, but that's okay, it goes to 10. That's fine. You could scroll back around if you wanted to. Problem is, when you get to 5 again, it doesn't display. It'll run 5, it just won't display it. So somehow it's not picking up the whole display loop. When you select, I have a loop for that select function, and it's just now look, if I hit 10 and I run 10, it won't show you 5 or 10 when I scroll back through. Counts down here. Okay, so now look, when I go, it goes to 15, 19, back to 0, 5, it doesn't show you, 10, it doesn't show you, 15, it'll show you. I mean, you could just, if you like 15 minutes in the tub, you could just never press that button again, and you don't need to see it again, but it would be nice to be able to see how many minutes it's going to be set for. So another option, though, would be for, now look, if I just hit start again, it's not going to show me the 15 minutes, but it'll run for 15 minutes, pump comes back on. Now I can hit start again, turns the pump off, but the timer's still running. See, turns the pump on for 15 minutes, turns it off. And sometimes it was turning it off. Because you could turn the pump off, and then, but this is still going to count down until it runs out. So that's a quirk that I need to fix. I need to figure out why it's doing that and try to fix it. And the other thing is that, and see, now it's stuck. The pump is off because I already turned it off, so it's not turning the display off. That's actually a clue. Because the pump is off, it's not turning the display off. So if I hit it again, then it turns it off. Once it gets to 0, if I hit it again, it turns it off. That's kind of a clue too. I should think about when I'm looking at the software. But anyhow, so here's the float switch. If I press this, that means there's no water in the bathtub. So I can still select. I was able to select. No, it's not letting me select anything. It's not working the way it was. That's interesting. When I have the USB plugged in and I test it, it's working different than it is whenever it's plugged into the AC. Why would that be? So now, okay, if I press and hold, the water's low. I can still select through. Can't see 5 because I ran it already. I can select through them, but it won't start. Nothing will start. That's good. I have an if statement that says if that is pressed, do nothing. And so if I release it, I can run the 10 seconds. Then while it's running, you let the water out of your bathtub. It turns the pump off right away. But this still counts down. I wish it would stop the counter when you press the button. It still counts down. That's not a big deal. Mainly, you let the water out, the pump won't burn up. It turned the pump off. So, but if the water is still out of the tub, it's not full yet, and you hit the start, okay, it's still not doing nothing, and it's still letting you select. So that's good, and it's still not turning on. Now you fill the tub up, you hit start, okay, it's running. So I mean, it's it's usable like this, but there's definitely some quirks that I need to work on. So let's take a look at the software. Okay, so here's what I got. I got a bunch of variables here. These are constants. These are my inputs. Switch 3, switch 2. It's my float switch. I definitely need better comments on here. Start button is at this pin. Pump output is pin 13. Here's a timer running variable. These are switch states for debouncing the switches. And I saw this volatile integer countdown time because I was using it in two different places. And I heard that if you use volatile, it makes it like important so the compiler won't mistakenly delete it in a second place that it doesn't think it's used. Something like that. I don't know. Anyhow, here's Millie's stuff. Last time state changed, all for debouncing. This is I can change how many milliseconds it ignores a second switch press so that it's not, you press it one time, but in real physical world, it might bounce on off, several times for a couple milliseconds. So anyhow, here's my time to wait is 19 seconds at the moment. Actually, I need to change that to 20 because anyhow, here's runtime starts at 0, elapsed time, current time. These are all variables that are used. They're unsigned longs because millis will keep running for 40 days or something, I heard, before it loops back to 0. So these could be really big numbers. Previous time, display. Here's my setup serial. I don't really need that, but I was using it for troubleshooting. Set up serial. I just told it these three are inputs and the pump pin is an output. Reading this state to give it a last switch 1 and switch 2 state. Start time is equal to millis, so it sets start time to millis. This makes pins from 4 to 11 outputs for my display. And then this is an interrupt that I watched a couple videos and learned about interrupts. I need to learn some more about them. But this is what allows it to break out of that loop. Because if you let the water out of the tub while the timer is running, nothing will happen until the timer is done running, and then it starts the loop over. So this allows it to break out of that loop if it's halfway through the loop. The timer is running down to 0. It's halfway through that loop, and somebody lets the water out of the tub. This switch 3, if switch 3 goes low, it will break out of that loop, and this is what it will do. It will debounce the switch, and then because if 3 goes low, debounces the switch, and then writes the pump pin low, turns the pump off, and it sets the countdown time to 0. So that's not working though for some reason. It does not set the countdown. It does set the countdown time to 0, but you saw the counter was still running. So that's not working quite right. But the main thing is it does turn the pump off right away if somebody lets the water out. So now that's all in the setup. So now in the loop, the first thing I have is this little function I created called set time. So if we go over here to set time, this is all just debouncing switch 2. And then, it resets the last state to the new state. Anyhow,
it sets switch 2 state to read switch 2 pin. So it reads the pin and says, what is it? Set this high or low, depending on what it is. If it is low, and if the runtime is less than 20 seconds, 20,000 milliseconds, 20 seconds, make the runtime equal to runtime plus 5,000. Well, we start with runtime at 0. I believe it was 0 up here. Runtime. Where's my runtime variable? Oh, right here, yeah. 0. So we start with runtime at 0. So it is obviously going to be less than 20 seconds. So if it is less than 20 seconds, add 5 seconds to it. So it becomes 5 seconds, right? And then when it goes through this loop, and so then if the runtime is greater than 1 second and less than 5 seconds, display 5. Now this is a function. I wrote a function for every number. It's over here in display digits. So these are all the integers that say segment A, B, C, D, G, E, F, G, and H of the 7-segment display. This just says what pins they're on. They're on pins 10, 11, 10, 9, 8, 7, 6, 5, and 4. Those are the pins that the LEDs are on for each segment of the 7-segment display. And so I have a function called off, which just makes all of them low. So the display is off. Here's 0. It makes these ones high. I hate that box. Makes these ones high and these two low, so that it will display a 0. And 1, 2, the combination display a 2, the combination display a 3, all the way up to 19. 19, right? So that's what this whole thing, this whole page is for all these functions that display all of the digits. So back to set time, if the runtime is greater than 1 and less than or equal to 5, display a 5. If it'll run through the loop, then it'll run through this loop. And if you press the button again, it's already going to be 5, so it's going to add another 5 to it. So then it's going to say if it's greater than 1 and less than or equal to 5, it's not. So it's not going to do anything. Then it's going to go to the next one and say if it's greater than 5 and less than or equal to 10, display 10, which it is at this point. So then it's going to display 10. And that's how it just goes through 5, 10, 15, and 19. And then otherwise, else, set the runtime to 0. So that is my loop for selecting the time. When I press the select button, it cycles through 5, 10, 15, and 19. So could be something with this that for some reason it will not display the 5 once you run it. So anyhow, let's go back to the loop. So the first thing we did was we set the time. We came over to here, ran this function, and we set the time. And now this is how we stop it from doing anything else if the water is low. So first thing we're going to do is we're going to read pin 3, and we're going to set switch 3 state to whatever that is. And if that state is low, write the pump pin low, like turn the pump pin off. But I mean, typically at this point, it's already going to be off anyhow. But it's writing it low. So nothing will happen if the pin is low. Else, which means if the pin is high, then do this, which is switch 1 is the start switch. So it's debouncing switch 1, and then it says if the switch is low and if the pump state is high, make it low. So this is like just seeing if the pump state, this is actually toggling the pump state. I need better notes on here. This is toggling. So anyhow, if you're making it low, then turn the display off and write it low. digital write the pump pin to the pump state, which is low at this point. Else, start the millis, make start time equal to millis. Did I have that up here somewhere? Oh, no, that was previous. Okay. Else, if it's not low, if it's high, then make the start time equal to millis. So that resets the timer to whatever millis is at this moment. So that starts your start time. And then make your pump high. Change the pump state to high, and then write the pump pin pump state. So this basically makes the pump turn on. And we finish that loop, which I don't like that we start this new loop for the countdown. I think that could be causing some of my problems. But every time I try to put this loop in here, it gets worse. Worse things happen. So anyhow, this is where we're at. So then after that loop, then it says if the pump state is high, which we just wrote it high, so it is, toggle the timer state. Timer running equals not timer running. So if the timer is running, then start the timer. Elapsed time, so we started the time right here. We made millis the start time. So millis is the start time. So elapsed time is going to be millis minus the start time. That's how much time has passed since we started this. And so now the countdown time is going to be equal to the run time, which is what we selected over here, the run time, right? We selected 5, 10, 15. So it's going to be, the countdown time is going to be equal to run time minus the elapsed time. So that means if we set it to 15 seconds, if we set this to 15 seconds, countdown time is going to start subtracting the elapsed time from it. So as millis runs, this run time, the countdown time is going to start at whatever we set it at, and it's slowly going to get smaller, right, until it gets to 0. So countdown time is going to slowly get subtracted every time through this loop. And so that's how it runs backwards, right? It's going to count down. And then this is just a simple, I had this actually in its own little function over here too, but then I was having problems and I wasn't sure if it was because I put this in a function. So I brought it back. And it turned out not to be the problem, but whatever, we still have this here. There's a ton of cleanup that can be done on this program anyhow. But anyhow, so now that we have our timer running, it's counting down now. And this loop says if the countdown time is less than 100 milliseconds, then display a 0. And that's why whenever it counted down, you saw it went to 0 real quick and then turned off. Displayed that 0 for a split second. And then it just goes through all the numbers. If countdown time is greater than or equal to 100 milliseconds, but less than or equal to 1 second, then display a 1. Display a 2, 3, it does that all the way up to 19. Right? Else, otherwise, if the elapsed time is greater than or equal to the run time, then turn the display off. Actually, elapsed time, that could be a issue. Run time, I guess it's the same thing, but this is not running backwards anymore. I mean, they were all running forward initially. It was counting up. And then I changed this to count down, but elapsed time should be, I should say, if countdown, I could make this easier. If the countdown time is equal to 0, then turn the pump, then display off, which just turns the display off. I mean, it's working. This part of it's working right now, so I'm going to leave it be for now. But this could actually just be if the countdown time is equal to 0. Then turn the display off, set the pump state to low, and write it. And that's the whole program. That's it. So if anybody has any ideas, I'm going to keep working on this. I watch a lot of YouTube videos. I get different ideas from other programs that people write, and I see if I can use pieces and parts, and things will, sound like a clue to me when I'm watching a video about someone else's program, and I'm like, oh wait, maybe I can try that to see if that solves this problem or that problem. But anyhow, that's where I'm at with this. I don't know, I hope somebody thought this was interesting. I think this stuff's really cool. And if anybody has any ideas for me, leave them in the comments, and stay tuned. Hopefully pretty soon I can make another video about this and show it working perfectly. All right, thanks for watching, everyone. Have a good one.